Now that we have talked about how to create the charts, we need to discuss three important managerial decisions surrounding control charts. First, we need to select points in our processes that need or would benefit from SPC. Second, we need to determine the appropriate charting technique. Basically, which types of charts should we be using? And third, you need to have clear policies and procedures for use of SPC. For example, if a statistical signal is received that a process is out of control, do you shut down the production line? As another example, how often should you be resetting the control chart limits? Something we haven't really talked about in this course. So let's recap which control charts should be used when. If you have fractional data, in other words variables, then you should use both the mean and range charts. You should collect at least 20 or 25 samples, each of size n equals 4 or 5 or preferably more. You would then compute the sample means to aid in creating the X-bar chart and the sample ranges to help construct the range chart. Then you would continue to sample with size n to track the process. You would use a p-chart if your observations are attributes that can be categorized into two states, the binomial distribution, so things such as good or bad. You would also be interested in the fraction or proportion or percentage of the defects. Because of this, you would have several samples, each with many observations. In our data entry example, each person had n equals 100 records that were tested. For a C-chart, we again have attribute data, but this time it is defects that can be counted, so more than two possible outcomes. Additionally, the number counted is a small part of possible occurrences. Examples include the number of typographical errors on a page or in a chapter of a book, and possibly the number of scuff marks on a hallway floor. So far, we have mostly focused on determining if a process is in or out of control based on if any sample statistics fall outside what I like to call the band of quality, the limits. However, a process can also be considered out of control if certain patterns are present in the sample statistics. Please note that the patterns we are going to talk about now mean that the x-axis must be time. Going back to our data entry example, because the x-axis was people, not time, patterns have no meaning whatsoever. So we see in this picture a normal pattern for a process that is in control. We would like to see that. This picture shows what we've been discussing up until now. A single point above, in this case, or below the limit indicates that the process is out of control and that we should look for assignable causes. If there appear to be trends, either upward or downward, then we would want to investigate for possible assignable causes. The book suggests 5 sample plots, but your policy may be more or less than 5. Another cause of concern would be if 2 consecutive plots are very near one of the control chart limits. Here we see at the bottom. In essence, this is saying that the sample statistics do not appear to be random. If there is a run of 5 points above or below the center line, then we would want to investigate. Again, the sample point should be randomly distributed between 2 limits, and this pattern violates that assumption. The final pattern is aptly called erratic behavior. Basically, it looks like the plots are jumping around a lot. This pattern is more difficult to identify, but there are ways to do it. So, for example, you could look for changes of more than 2 standard deviations between consecutive points. So this finishes up SPC charts in Supplement 6.